This video is trigonometric ratios in right triangles. So hopefully you guys have had some time to look over those other videos in the links to the side and have some information about what is trigonometry. So we are just starting kind of this big, long, fancy word, trigonometric. This just means measuring triangles. So we're measuring the ratios of triangles in right triangles. Now, there are three special sides we have to deal with, and we'll talk about those in a minute. And we'll also talk about our SOHCAHTOA formula. So let me just change that. I'm missing the L there. Okay. So first we need to identify our angle. This is the easiest step. They're going to give you one angle they want you to consider. I am sine of B. So the angle I'm concerned with is beta. It's not B, it's beta. Okay. So now that I have beta, I need to identify the hypotenuse, the opposite, and the adjacent. So the hypotenuse in a triangle is just the longest side of your triangle, and that will never change. So in this case, I have 3, 4, 5. Which side is longest? 5. So 5 is my hypotenuse. Next, I have to consider the opposite. The opposite side is the side that is opposite of your angle. So if I'm starting at my angle, imagine my eyeballs are starting right where my angle is. What they're going to see opposite of them is this side over here. So we're going to say 4 is the opposite side. So we're going to say our hypotenuse is 5, our opposite side is 4. And then once you've found these two, your adjacent is just whatever's left over, the third side. But if you did this correctly, your adjacent should be the side that is next to your angle that is not the hypotenuse, because both the hypotenuse and the adjacent are next to your angle. But what the word adjacent means is it means next to, and so it's a good thing that this is next to as well. Sometimes it might seem like this should be adjacent, but that will never be the case because this will always be a hypotenuse. The longest side should always be the hypotenuse. Okay, so we have found our hypotenuse, opposite, and adjacent. So they say use the appropriate SOHCAHTOA formula. All right, so how do I know which formula to use? Well, we have SO, which is for sine, Ka, which is for something called cosine, and TOA, which is for something called tangent. The O here stands for opposite, H stands for hypotenuse, the A here stands for adjacent, H stands for hypotenuse, the O here stands for opposite, and A stands for adjacent. And so basically all these formulas, they say this thing equals this divided by this. Cosine equals adjacent divided by hypotenuse. Tangent equals opposite over adjacent. So in this case, they want to know sine. So we are finding sine of B, or I keep saying B, it's really beta. Sine of beta equals, and according to this, it should be the opposite over the hypotenuse. It should be opposite over hypotenuse. And we know in this case, our opposite is going to be 4. And our hypotenuse is going to be 5. So we are going to say the sine of beta equals 4 over 5, which in this case is going to match with B. So B is going to be the correct answer in this case. And that's what we're going to do for each one of these problems. So mathematically, conceptually, I don't think these are very difficult. But you do kind of have to realize what is this formula over here, and you kind of have to know how to work it. And you also have to identify these things, and that really has to do with understanding definitions, kind of like understanding perpendicular bisector or something like that. It's not really difficult to understand what it is, but it can be difficult to remember what the words actually mean. So let's get rid of this one and look at another one. Okay, so they want us to find, did I do this in the correct order? Okay, so let's look at this one next. Okay, first we're going to identify our angle. Our angle is a beta again, it's up here. Okay, so this is my angle. Next we want to identify our hypotenuse. Hypotenuse is the longest side, so this is going to be our hypotenuse. Then we want to identify our opposite side. Well, I'm starting at this angle, so my opposite is going to be 3. And we want to identify the adjacent. The adjacent's whatever's left over in this case, so that's going to be A. It should be next to B, and you can kind of see how it's next to B. Okay, so they want us to find tangent of B. And so if I'm looking for tangent of b, I'm going to look down here and I'm going to say, well, sine, no, cosine, no, tangent, yes. So tangent, it says opposite over adjacent. So I'm going to say the tangent of beta is opposite over adjacent. And in this case, opposite is 3, adjacent is 4. So my final answer is going to be 3 over 4. That's going to be B in this case. Okay, let's try another. So, whoa. Okay. So same steps as always. Nothing's going to really change about that on this exercise. So in that way, it's kind of nice and consistent. So if I look, I need to identify my angle. My angle is this guy up here. This is my beta this time. And they want us to find cosine of beta in the triangle. So my hypotenuse is going to be the longest side, 17. My opposite is going to be this 15 across from the beta. So this is going to be my opposite. And then finally the adjacent is going to be this 8 over here. So if I want to find cosine of beta, well, sine, no, cosine, yes. I need adjacent over hypotenuse. So cosine of beta should be the adjacent side over the hypotenuse. And in this case, my adjacent side we said was, if we look over here, 8. And my hypotenuse we said was 17. So in this case, we're going to say the cosine of beta is 8 over 17. And that looks like option D in this case. So that's going to be our correct answer. Okay, I'm going to wrap up the video here. If you have any questions, feel free to email me. We'll also have our scheduled class meeting time on Friday afternoon. Make sure to check what time it is, and you can kind of join our Zoom call for that if you like. Okay. You can talk, yeah.
Okay.
Sorry, I'll take off my hand.